Hello and welcome to today's talk on how open source can transform traditional HCI. I'd like to talk to you today about why I believe the data center needs more open source and how open source technology can innovate and propel the future of on-prem and edge infrastructure. So to start, I'd like to first talk about the current state of the data center and some of its challenges. For one, the data center today and edge still rely on primarily proprietary APIs to manage the infrastructure level concerns, such as compute, storage, and networking. Hardware, in fact, is often coupled with infrastructure management software as well, and over time this can become inflexible and brittle as technology needs change. And then finally, as data centers have evolved in size and complexity, there's more diversity in the computing environment. There's more types of infrastructure, types of hardware, and it's really difficult to unify and drive agile operations out of all of this complexity without open standards to unify the technology. And so this is why I think open source and open standards would benefit the data center and edge today. And so I want to present an idea of what an ideal solution or an ideal stack would be. And we'll start with this on the screen here. So one of the things you might notice first off is Kubernetes is the unifying API across all these infrastructure types. The CNCF has done an amazing job at developing truly open standards that are vendor neutral and that have effectiveness in many different industries. And so we have a unique opportunity today with a technology like the Kubernetes API to apply this in more places and in more contexts to achieve that truly unified language for addressing compute needs. I think it's very exciting. Now, the one challenge becomes, in some cases, while Kubernetes is largely now a commodity in the cloud, Kubernetes in the data center and in the edge, it does require some layers of software in between to take that bare metal compute and produce a Kubernetes API. And here's where largely today in this middle layer, there's still a lot of dependency on proprietary technologies that have to be sort of molded or conform to the Kubernetes spec to produce this end goal. And so this is where we thought about, is there some ways that we can use open source to optimize this middle space for running Kubernetes and for running really any virtual workload. It doesn't just have to be Kubernetes, but Kubernetes is providing us that universal experience that so many of us want. And so this is where we start this conversation and this exploration. So Kubernetes can become the unifying API standard across all these types of hardware in the data center and at the edge. And converging all these types and including the cloud creates truly universal computing. Right now, I can deploy an application to the cloud and the data center and the edge using the same tool set with the same CI/CD system, with the same monitoring and observability tools, and with the same expectation of functionality. I'll have the same load balancing expectations and service discovery and config management expectations across those environments. And then finally, in this model, operators still retain choice of how they implement Kubernetes in a particular location. So as you see, there's layers below Kubernetes that we can swap out with different components. Harvester is not a requirement. It's just one method, which I think you'll find is beneficial. But perhaps there's another way that you want to achieve that Kubernetes layer for your applications to converge with. And so this is what Project Harvester is about, is to provide that level playing field and integrate the metal and the hardware layer as closely as possible with the Kubernetes goal, or the Kubernetes layer on top, and provide the most efficient and open way to achieve Kubernetes and to achieve modernized HCI. And so it is an open source hyperconverged infrastructure solution. And so it provides all of the concerns we would expect from a traditional HCI solution, such as virtualization, network virtualization, software-defined storage. And it combines all these technologies that it uses into a single API. So it's using technology such as KubeVirt, KVM, Kubernetes, Multis, Longhorn. And so these are all well-known open source projects that all have their own history and track record that is being built on top of to create a more powerful sum of all its parts. And this is designed, of course, to work on bare metal and transform bare metal into a cloud-like API experience. And so Harvester really is about increasing IT value. We're using existing hardware to create a unified HCI experience. Harvester doesn't have this expectation of customized hardware or this special dependency or coupling with a hardware vendor. It's an open, hardware agnostic approach to HCI. We can normalize the differences now between data center, public cloud, and edge because we have this consistent experience. And then when we want to use Kubernetes, now we have best-in-class Kubernetes support with the Rancher integrations that we're able to provide into the stack. And so some of the features to mention are, I think really things that we'd all expect from an HCI solution ultimately. But you can see this on the screen here. We've got VM lifecycle management, create, update, destroy type functions, cloud init support for bootstrapping servers, out-of-band kind of KVM-like console to access the VM, SSH key injection. There's storage management that's built in. So Longhorn provides the software-defined storage that allows us to converge the physical hardware storage into virtual machines. Network management is built in. So we have software-defined networking through various CNI technologies and technologies like Multis, which allow us to work with multiple network interfaces. And finally, there's an image management function to help us manage virtual machine images within the Harvester context. And so the Harvester architecture looks something like this. We take bare metal, the node. We run a optimized Linux kernel and a Linux operating system that is optimized for the use of HCI. And in this, we optimize for KVM and KubeVirt, and then our storage technology, Longhorn. They're all embedded into this layer to work for a purpose-built goal, which is to produce virtual machines and to be an HCI system. VMs then run on top of this layer as virtualized hardware emulated guests. And we, of course, in those VMs can support any x86 operating system because this is hardware emulation. So as long as it can boot into x86, so Windows and Linux and even OS X, if you will, or other operating systems that might boot into this platform can all run as virtual machine guests here. And then finally, we bring that all together with software-defined networking to allow the VMs to be bridged back to our physical networks through VLAN tags or through other types of bridging, or CNI perhaps, or other SDNs. Deployment is through an ISO. So we have an appliance-based model of this. Again, we're trying to converge that bare metal hardware, as you see on the right, into a cloud-defined, cloud-like API experience. So we want to take that hardware, and you should be able to boot it right into the Harvester experience, either from an ISO or a PXE boot operation where you can image a whole data center. And so finally, we'll get to the fun part, actually, which is not slides, but we'll take a look at the technology itself. And for this part, I'm pleased to work with a colleague of mine who will now take us through the demo and show us more. So Guangbo, if you want to take it from here, I'll virtually pass it over to you. And thank you, everyone, for your time. And we look forward to your questions and engaging with you further on this open source project.
Hello, guys. Welcome to the Harvester online demo. So in this presentation, I will be giving a demonstration about the Harvester 0.2 version. And if you are new to Harvester, you can visit the harvesterhci.io website and downloading the latest ISO image from the GitHub page. And once the image is downloaded, then you can boot your server using this Harvester ISO image. Additionally, Harvester also supports PXE boot, so you can use your existing PXE server to do a batch installation. As well as we are compatible with some bare metal cloud service providers, for example, like Equinix. So you can using Equinix machines to install the Harvester. And now I will be started by giving an installation demo first. So in here, I have prepared a Harvester server. And as you can see, the first option is you can either choose to create a new Harvester cluster or you can join an existing one. For existing cluster, you will need to input the harvest server URL and the token to join the cluster. And in our case, we will choose to form a new cluster. So for the next step, you will need to select the disk where you want to install your harvester, and followed by the next configuration, which is host name and network configuration. So let's specify a host name, and for the management nick, you will need to choose one which is implied to the cluster management network. And you can either choose to use a static or DHCP network configuration. And let's choose DHCP in here. And the next step is to configure a cluster token where others will join you to form a cluster. And you will need to specify the password to log into your node. And followed by some optional configurations we can skip for now, and click yes if you are ready to install. So normally the installation will take a couple of minutes. And in here, let's take a look of a running example. So once the harvester is installed, you will be given a management URL and a status. As an admin user, you can log in using the password you have configured by pressing F12, and you can run any commands to manage this node. For example, like get node. So now let's take a look of the harvester UI. And for the first time login user, you will be promoted to set the root password for the admin. But as I have already configured, so let's log in with using the username of admin and the password I have configured. So once logged in, on the dashboard page, here you will get a summary of resources, for example, like the host, virtual machine, networks, image, and volumes. And underneath, you will be able to see the CPU, memory, and the storage usage and events. So on the host page, you will be able to see all the nodes that have been joined to the current cluster. And by default, the first one is always the management node. And when you're having more than or equal to 3 nodes, the first 2 nodes will be promoted as a management automatically. Therefore, you will get a 3 management node. And other remaining node joined after will become in the worker node. Now let's take a look at one of the node. So in here, you will get more detailed metadata info of this node, and you can check the VM instance. So as an admin user, you could turn this host into a maintenance mode, which will stop scheduling the new VMs to this node, as well as it will gradually migrating the existing VMs to the other available node. Therefore, you could doing some maintenance work against this node. And you can also doing some configuration. For example, starting from 0.2, now you'll be able to specify a different nick per node for the VLAN network configuration. Now let's take a look of other pages. So in the virtual machine page, you will be able to see a list of VMs that you are currently running. And the volume page, you could see the volumes attached to the VMs. And on the image page, normally that's where the user will get started. Now let's try to creating a new image in here. So in order to uploading an image to the harvester cluster, you will need to specify the URL address. Normally for an internal server, you could run an HTTP server and uploading your custom images to your HTTP server. So for example, in here, I could copy the URL link of my custom image and paste in here. So once the image is created, actually it is not get uploaded to the Harvest server yet until the first VM is created using this image. And because currently Harvest is powered by the Longhorn, so on the same node, if different VMs use the same image, then actually it will sharing one base image. And by this design, it will significantly reduce the storage consumption and speed up the boot up time performance. Now let's take a look at some advanced tabs. So on the network page, this is a place where you could create a VLAN network. And by design, Harvest uses a bridge VLAN, which will using a physical NIC as a bridge layer. And let's create a few VLAN networks in here. Also, you can check your SH keys and you can configure some cloud config templates to reuse it in the VM creation later. For example, you could specify the root password for some cloud images. And now let's go to the VM page and let's creating a new VM. So for example, I could create an OpenSUSE using the VM templates. So in here, I got ISO templates, and those templates are predefined by the harvester. So you could use it directly, or you could create your custom one. On the volume tab, we get two disks, one for the ISO, another one as a load disk. So on the network, you could either choose a management or VLAN network. And advanced options are mostly for cloud image, so we don't need, just create. And then the VM will up and running in a couple of minutes. So what actually happening behind the screen is we are calling a KubeVirt to create a VM, and the KubeVirt will actually make a call to the libvirt API, and it will run a QEMU KVM in the bare metal server. So once the VM is up and running, then we could click the console to view the installation. Now let's click the installation. And apart from OpenSUSE, we are compatible with any other popular operating systems like Ubuntu CentOS, and you could try out in the Harvester. And meanwhile, it is installing. Let's take a look of the VLAN network in Harvester. So in here, I created different VLAN VMs. In one is 178, and the other two are running on VLAN 188. So in the VLAN 188 VM, let me print the IP. So let me zoom in a little bit. And the IP is 188.10. If I do AR ping to another VLAN, it's the same 188. It should work. AR ping the IP. As you can see, it's reachable. And if I try to ping the VLAN 178, it should not work. That's expected. And let's just ping. Oops. Let's just ping another VLAN network, and it's also not reachable. So VMs cannot talk with each other if they are not in the same VLAN. Let's just skip the ISO installation, as this is just a standard procedure. Now let's take a look of some advanced VM actions. For example, you can take a backup, doing a VM migration, and also generating a templates. Let's take a backup first. For doing a backup, you need to specify the backup target first. Currently, both NF server and the S3 compatible storage server are supported. So in here, I just use the NFS. So what we can do is let's try to write a file into the VM. For example, let's equal the full to the bar file, and let's check the bar file is correct. Yep, and let's sync to save the memory, and now you can do a backup. Now let's create a backup. So what this actually is doing is it will calling the CSI snapshot and the Longhorn backup feature to creating the backup file and save the data volumes into your configured backup target, which is outside the cluster. And later you can either choose to restore as a new VM or replacing the existing one. And my second favorite feature is now we can do a line migration of the VMs. So for example, you will need to select the target node where the VM you want to migrate to. So let's try to open in the terminal first. And let's try to create a new file, for example, the text.txt. And let's try to write some text in here. So line migration. And now we can start to migrating the VM from the node 1 to node 2, or maybe, yeah. So now it's start migrating. And meanwhile, let's try to type more words to make sure that every memory data is saved while doing the migration. So that's no downtime. It's save. Okay, let's check text. And let's check if the migration is done. It's still migrating. Okay, so VM has been migrated to a target node. So let's check the file again. And okay, everything is saved. So this is live migration that users can enjoy zero downtime of migrating a VM. Now let's check if the backup is ready. It's still progressing. Okay, so now let's check my last favorable feature, which is a Rancher integration. So you can configure a Rancher dashboard in the setting by enable it. So on the top right corner, there will be a Rancher dashboard link. Let's click and you can skip the certificate warning. By default, you will only get a local cluster, but as we have added the Harvest node driver, which you can use to spin up the Kubernetes cluster in the Harvester. So for example, let's try to create a new Kubernetes cluster using the Harvest node driver. And for a new cluster, you will need to specify the name and select the node roles. So a name prefix is literally the VM name prefix. And you will need to create a node template. For the node template, you can select either internal Harvest cluster and external. So in our case, this is an internal Harvest cluster. And for the node instance, you can specify CPU, memory, the disk size, and the disk bus. Also, you need to select a cloud image, and currently is network only support VLAN network, and it's a user to access to the cloud image. Let's create a template. So once the configuration is done, so below you can adjust some Kubernetes configuration. So let's click Save. So what this does is a node driver will calling the Harvester API to creating a new VM, and the VM will install the Docker and as well as some required Kubernetes components in the node. Also, we could add more node to the existing cluster. For example, you could check the new node. And now let's try to deploy a container that runs inside the Harvest VM. For example, let's create an Nginx port, and the image should be Nginx at port 80 and create. So once Nginx is running, we should be able to access it. And it works. So that's all for the demo, and let's recap quickly about what Harvest is. So Harvest is an open source HCI built on the Kubernetes. In Harvest, we're providing basic VM lifecycle management, including SH key injection, cloud init configuration, and graphical or serial port consoles. Also, we're supporting some advanced features like VM line migration, VM backup and restoring. Also, we do supporting some management network or VLAN network for the VMs, as well as we do have a built-in rancher integration and the Harvest node driver, which you can use to spin up multiple Kubernetes clusters inside the Harvester. And also we do supporting a PXE for mass and automatic installation. And that's all. Thanks everyone for watching this demonstration.